I received multiple questions about 18F post-class assignment, problem number 4 and number 5. All right, so number 4. We have initial velocity of the proton. It's given, it's only in the x direction. There is an electric field in which it travels. Since this travels in this electric field, there will be electric force. It coincides in direction with the electric field because the proton is a positively charged particle. So the trajectory will bend and eventually the proton will fall on this plate. We need to find the distance, horizontal distance it traveled. So there was a very similar problem in physics 211 before the first midterm, but at that point you were dealing with the force of gravity, not the electric field. But other than that, this is an identical problem to this. So let's consider the solution of this problem. I will only give you some idea of the solution. Okay, you'll have to substitute the numbers yourself. So let's consider this problem. This is a 2D kinematics. And 2D kinematics starts by writing the kinematic variables, what we know and we don't know, and in both directions, and x and y. So let's start with the x direction. Delta x is unknown, and this is what we need to find. The initial velocity in the x direction is known to some number. The final velocity is unknown. The acceleration in the x direction is actually known because there are no forces in the x direction, and therefore Newton's second law tells us that the acceleration in the x direction is 0. The time particle traveled is also unknown. So there are too many unknowns, okay? So in order to solve the kinematic equation, we need to have 3 known variables. So here we have only 2. So there are too many unknowns and we will not be able to solve this problem by just using the x direction. So and therefore we will proceed to the y direction as well. So we know the distance the particle travel in the y direction. Okay, so it's gonna fall on this plate. So this distance the particle travels is given by this r. So it's some number. Okay, don't forget the negative sign over here because delta y is actually negative. The particle goes down. The initial velocity in the y direction is 0. The final velocity in the y direction is unknown. Now, what about the acceleration in the y direction? Actually, we can use Newton's second law again to find this acceleration, and it's given by the y component of the electric force divided by the mass. And okay, as a matter of fact, the electric force only have y component in this problem. And how to find this electric force? It is given by the charge of the proton times the y component of the electric field. And once we substitute all the numbers, we should not forget that this is actually negative. The electric field points directly down. Okay, and here I just put the magnitude of this electric field as some given positive number. The charge of the proton you know. Okay, and therefore you will be able to find the acceleration in the y direction using this equation when again the mass of the proton you know. Okay, so now the time, the final kinematic variable, is unknown, but there are 3 kinematic variables we know. This is delta y, the initial velocity, and the acceleration. And therefore we will be able to solve this problem and find, for example, time. But the time is a common variable with also motion in the x direction. And therefore, if we will determine time, we will be able to solve the kinematic equations in the x directions as well. And once we solve this kinematic equation in the x direction, we will be able to find delta x. Okay, so let's proceed. So now we will have to find the appropriate kinematic variable, which involves time, involves other known variables, and time is unknown, but the other variables which enter into this kinematic equation are known, and therefore we will be able to find time. So in this case, the initial velocity in the y direction is 0, so this term would not contribute. Okay, so the only terms which contribute is delta y and 1/2 times acceleration in the y direction staying times t squared. So let me rewrite this equation over here. I can proceed and solve this equation for the time. Okay, so here is a solution. I will be carefully substituting delta y and ay. Both of them are negative. The negative sign will cancel, and at the end of the day, I will get a positive number under the square root. Okay, so and I will be able to determine time. So now with this time, I will be able to proceed further. I can use this time. It will be a number now, okay? And I will substitute it into my kinematic equations in the t direction, right? So now it will be known. So here we go, back to the x direction. Delta x is unknown. The initial velocity in the x direction is known, it's given. The final velocity is unknown. The acceleration is known in the x direction, and time is known. Okay, so we know three variables, these two and this one. Okay, since we know three kinematic variables, we'll be able to solve this problem. So we actually need to find delta x. Okay, so delta x, again, I will use the same kinematic variable is given by the initial time plus 1/2 acceleration times t squared, but the acceleration is 0 in the x direction, and therefore this is just a simple equation, delta x given by the initial x, which is given, and t, which we computed. We will substitute the numbers, and we will get the final result. That's it. So now let's proceed to the next question. So the next question is displayed over here. There is electric field. There is a pendulum with at the tip of the pendulum there is a charged particle. It has a positive charge. Okay, so this is one body problem. So the angle is given over here. This is one body problem, and therefore we will have to start by defining all possible forces on this charge. Well, there is electric force. There is force of gravity, and one shouldn't forget about physics 211, there is also the string tension force. The string tension force has two components, Ty and Tx. Well, it's kind of obvious here that Tx is negative, Ty is positive, Tx is negative, Ty is positive. Yeah, so Ty is positive. So now this angle is adjacent to the Ty component, and therefore Ty is given by T, the magnitude of T, times cosine of alpha. Okay, and for Tx you'll get this result. Make sure that you understand why this is true. Okay, fine. So now everything is at rest, right? So this particle is at rest, it doesn't move, and we can apply Newton's second law in both directions, in x and y direction. Well, let's start with x direction. In the x direction, the net force is given by the mass times acceleration. In the x direction, particle doesn't move, and therefore this is just 0. Okay, what are the forces in the x direction? There is F electric, okay, over here, plus the x component of the string tension force. I will substitute what I found for the x component of the string tension force. It is negative T times sine of alpha, and I should remember that the electric force is given by Q times electric field. Okay, and since there is no acceleration in the x direction, this is 0 on the right hand side. So what about the y direction over here? So in the y direction, we will have the contribution from the gravity. Okay, I put minus Fg because the gravity directed straight down, so therefore this negative number over here. And instead of Fg, I will just substitute m times g, right? We know this result. So, and there is another contribution, it's Ty component. Okay, so in this case it is positive, and it's given by the T times cosine of alpha. All right, so now we have these two equations, and how many unknowns do we have? One unknown is T, we don't know T, and the other unknown is electric field. So these are the things we need to find. Okay, so, well, two equations and two unknowns, it means that we always can resolve the system. So let's start actually with y direction. So we can notice that once we find T from this equation and we substitute over here, we will be able to solve the problem. Okay, so I will first find T from this equation. So it's pretty straightforward. T times cosine alpha equals to mg, or T equals to this ratio. Okay, so now I will use this fact and substitute it into this equation. Okay, so let me rewrite this equation first in this form. And we just found that T is given by this ratio, which I am going to substitute over here. And then it simply will read that. Okay, what is sine divided by cosine? Well, it's tangent, right? So, and therefore Q dot E Q times E equals to mg tangent of alpha. Or we can solve it now for the electric field, and it will be given by this result. And everything on the right hand side, we can just substitute the numbers and compute it carefully. That's it.